Hello everyone, welcome back to my YouTube channel. I hope you all are doing great. Good to see you all here. So, before we move towards today's lesson and what today's topic is, can I get a quick like, share, and subscribe for more lessons and discussions? So, in the previous class, I explained some problems, but I made a small mistake in one of the solutions. Today, before moving forward, I will correct that mistake so that there is no confusion. In the previous class, we discussed exercise 1.1, first question, in which we had three questions and I provided solutions for all those. So the first one is correct, second is also correct. In third question, here I made a small mistake. In the last step, I asked you guys to comment down the HCF of this problem. So here Q is 127. This is a mistake. So Q is here 3 and HCF is 127. Okay. So this was a mistake. So note down and clear it and remove the confusion. So Q is 3, R is 0 and HCF of this problem is 127. Okay. So today we'll discuss example 1 and 2, which is in your maths textbook in chapter 1, which is in page number 6. Before we move to the examples, let me quickly explain the concept again in simple words. This will help you to solve problems on your own. The upcoming problems will help you if you understand this. So the key idea coming in the problems is division algorithm, and understand how every integer can be expressed in particular form. So keep this point in mind while solving. So all you need to remember is the division algorithm that we discussed in previous class. If you are not familiar with what division algorithm is, you can check out the previous videos. So look at this simple explanation. So see here, what happens if we divide 4 by 2? 4 if it is divided by 2. So 2 ones are 2, 2 twos are 4. So are you getting any reminder? No, right? Remainder is 0 here. So, if we divide 4 by 2, the remainder is 0. Okay. Next, what if we divide 5 by 2? If we divide 5 by 2. So, 2 ones are 2, 2 twos are 4. So, the number here is 5. So, we are taking 2 twos are 4. So, 1 is remaining here. So 2 into 2 is 4, but the number here is 5. So 1 is remaining here. So the remainder is 1. When we are dividing 4 by 2, remainder is 0. And when we are dividing 5 by 2, remainder is 1. So let us explore few more numbers. See here, if we divide 6 by 2, 6 when divided by 2, what will be the remainder? 2 ones are 2 threes are 6. So remainder is 0 as we are getting the required number. Similarly, when 7 is divided by 2, 7 when divided by 2, what will be the remainder? 2 ones are 2, 2 threes are 6. So here 1 is remainder as the number is 7 and we are taking 6, which is 2 into 3 is 6. So remainder is 1. So when we are dividing 6 by 2, remainder is 0. And when we are dividing 7 by 2, remainder is 1. So I think you are noticing a pattern that remainder is 0 or 1. So remember one thing, if remainder is 0, number is even. Okay, if you are dividing any two numbers and you are getting remainder as 0, the number is even. The number may be any integer. Okay, the number may be any integer. Next, if remainder equals to 1, number is odd. So whenever you are dividing two numbers, if you are getting the remainder as 1, the integer is odd, or else the number is odd. So what you understood till here? When we are dividing any two numbers, let's say A and B, if you are getting remainder as 0, the number is even. And if you are dividing any two numbers, let's say A and B, these are the two numbers, and if you are getting remainder as 1, the number or the integer may be odd, right? So even numbers look like 2q. Remember this form which is upcoming in the example, because there is no remainder. Are we getting any remainder here? No, right? Next, odd numbers look like 2q plus 1. As we are getting remainder is 1. Okay, if we are getting if remainder r equals to 0, it is of the form 2q, and if r equals to 1, it is of the form 2q plus 1. Same is here. Understand it with a real life example. Imagine you and your friend are sharing apples. So if you have 4 apples, you and your friend, if you are having 4 apples, you both share this equal apples, right? How many apples you each will get? 2 you will get and 2 your friend will get. So is any apple left here? No, right? No apple is left. The apple is distributed among you equally. Nothing is left. So if you have 4 apples, you both get 2 each and nothing is left. That even. When nothing is left, that is 0, it is called even. It looks like 2q. I already explained you. So if nothing is left, it is of the form 2q. And if you are having 5 apples, so if you are having 5 apples, you and your friend are sharing these apples. So 2 will be shared by you and 2 will be shared by your friend. So 2 plus 2 is 4. One apple is remaining, right? So this one which is left is odd and it is of the form 2q plus 1. So remember, if nothing is left, it is of the form 2q which is even, and if something is left, it is odd and it is of the form 2q plus 1. Okay, now let's take example 1 from the test book, which I already mentioned, which is in your max test book, page number 6. So I'll explain step by step and you can practice along with me. If you understand the previous example explanation, this example will be easier for you to understand. So observe carefully how this solution is written. Okay, so the first example is, show that every positive even integer is of the form 2q and that every positive odd integer is of the form 2q plus 1, where q is some integer. So the statement here is, they are saying that every positive even integer is of the form 2q, and in every positive odd integer is of the form 2q plus 1, where this q is some integer, means it can be any number. Okay, so let us recall what division algorithm is and what is the statement of division algorithm. A equals to bq plus r. Okay, so take any number a. This a, let us take any number. When we divide this a by 2, the remainder will be either 0 or 1. So in this equation, we had a condition in the division algorithm that 0 is less than or equals to r and r is less than b. Okay, so here the remainder will be 0 or 1 and b is here 2. Okay, so 0 is less than or equals to r is less than 2. So what will be your remainder? R is 0 or r equals to 1. R is less than 2, right? So less than 2, what you'll get? 0 and 1, which is written here. Okay, so we can always write a equals to 2q plus r. This is substituted in this equation. So a equals to, this b is 2 into q plus r. Next, where r is the remainder, remember we discussed in the division algorithm that q is quotient and r is remainder. So where r is remainder, when we divide by 2, the remainder can be 0 or 1. So if r equals to 0, then a equals to 2q. So take this equation, a equals to bq plus r. So a equals to, what is b? 2q plus what is r? 0. This r is obtained from here. How we are substituting? From this. From this statement, we will find what to substitute in r. So r is 0. So a equals to 2q. 2q plus 0 is 2q. Remember, in previous explanation, I explained you, if nothing is left, it is called even and it is of the form 2q. Similarly, if r equals to 1, then a equals to 2q plus 1. The number is odd. So let us look at this. A equals to bq plus r. So a equals to, what is b? 2. Q is written here plus what is r? R is 1. So plus 1. Okay. Something is left. The left thing is here 1. So if something is left, it is called odd. If nothing is left, it is called even, which is of the form 2q, and odd is of the form 2q plus 1. Okay, so that's why every even number is 2q and every odd number is 2q plus 1. Simply nothing difficult in this question. So we just need to show that every positive even integer is of the form 2q and every positive odd integer is of the form 2q plus 1, where q is some integer. Okay, so we will take division algorithm equation, that is a equals to bq plus r, and we have a condition that 0 is less than or equals to r and r is less than b. So what is b from this question? 2, right? So we'll substitute 2 in the place of b. So b, you'll get either 0 or 1. If we are putting 2 in place of b, so r is less than 2. Less than 2 will get 0 and 1. So r is 0 and 1. So if we substitute 0 and 1 in this equation, you will get A equals to 2q and A equals to 2q plus 1. Okay. So this is completely all about example 1, and in next, let's solve example 2. Here also we apply the same concept but with different numbers. The concept is very similar to the previous example 1. By solving this, you will see that the method becomes very easy once you understand the whole logic. So let's see the example. Show that every positive odd integer is of the form 4q plus 1 or 4q plus 3, where q is some integer. In the previous example, we were required to show odd integer as well as even integer. So in example 2, we need to show that every positive odd integer is of the form 2q plus 1 or 2q plus 3. Just look at example 1. What were the forms given and what the type of integers we found out. So let's move to the solution. So take any number A. Remember, here also we apply Euclid's division algorithm. So we can write A equals to 4q plus r. You'll be confused by here. Don't be confused. So what is the division algorithm equation? A equals to bq plus r. So we need to substitute here. A equals to, what is B given? 4q plus 1, right? What is B? 4. Okay. 4q plus r. So the r we need to find here. So the condition of Euclid's division algorithm we have is 0 is less than or equals to r and r is less than b. So what is b here? 4. So 0 is less than or equals to r and r is less than 4. So what will be the r values in this question? So values less than 4. So what all the values we will get less than 4? 0, 1, 2, 3. So all these are r values. We need to substitute in this equation and we need to check. Okay. Where r is the remainder and r can be 0, 1, 2 or 3. How you will get this? From this equation. In the Euclid's division algorithm, we have a statement that 0 is less than or equals to r and r is less than 4. This 4 is from this question. So the numbers now look like this. A equals to 4q. When r equals to 0, if A equals to bq plus r, A equals to, what is b? 4q, and what is r we are having here? 0. So 4q plus 0 is 4q. Therefore, when r equals to 0, it is 4q. Next, when r equals to 1. So substitute in the Euclid's division algorithm equation, that is A equals to bq plus r. A equals to, what is b we have? 4q plus what is r now in this step? 1. So 1. 4q plus 1 is 4q plus 1. Next, when r equals to 2. When r equals to 2, substitute in this equation. A equals to 4q, A equals to bq plus r, where A equals to, what is b? 4q plus what is r in this step? 2. So what you will get? 4q plus 2. Okay. In the first step, when r equals to 0, we got 4q. In this second step, when r is 1, we got 4q plus 1. When r equals to 2, we got 4q plus 2. And we have one more value, that is 3. We solved with 0, with 1, with 2. Now the last value we have is 3. So when r equals to 3, when r equals to 3, substitute in this equation. So what you will get? A equals to 4q plus what is r here now? 3. Okay. So you will get 4q plus 3. When r equals to 0, you will get 4q. When r equals to 1, you will get 4q plus 1. Next, when r equals to 2, you will get 4q plus 2. When r equals to 3, you will get 4q plus 3. Now, we need to check among these four equations which we got, we need to check which ones are odd. As in the question, they mentioned that show that every positive odd integer. Okay, they are not asking here even integer. They only asking what about odd integer. So odd integer is of the form 4q plus 1 or 4q plus 3. So among these four equations, now we need to check which one are odd among this. So 4q. If you remember in the example 1, I explained you if nothing is left, if the remainder is 0, it is even. Okay. So this is not odd positive integer. Next, 4q plus 2. 4q plus 2. It is even. Next, 4q plus 1 odd. So here something is remaining, that is odd. Next, 4q plus 3. It is also odd. So now what is the conclusion? 4q and 4q plus 2 are even. 4q plus 1, 4q plus 3 are odd. So if you want to understand how to identify these equations, like 4q and 4q plus 2 are even, 4q plus 4q plus 1 and 4q plus 3 are odd. So take two numbers. Example, we have 9. So how this 9 can be written? 4 into 2 is 8 plus you'll get remainder 1. So here in which form is this? A equals to 4 into q plus 1. So here remainder is 1. So if something is left in the remainder, it is odd. Okay. Next, if you take number 15, let us say A is 15. So how you can write this 15? 4 into 3 is 15 plus how much is written? How much is remaining? In the remainder, how much will be remain? 3. 4 3s is 12. 12 plus 3 is 15. I think here you may get you may also get a doubt that 5 into 3 will be 15. No, as in this question, B is given as 4. Okay. So we need to consider here B as 4. Do not get confused in this step. Don't take this B as other number. All the values of B are 4 in all equations. So 4 3s are 12 plus how much is remaining? 2. Okay. So 4q plus 1 and 4q plus 3 are odd numbers and 4q and 4q plus 2 are even. If you want, you can look at this 4q and 4q plus 2 by substituting any numbers. Let us take 8 as A. So how you can write this 8? 4 2s are 8. So are you getting any reminder? No, right? Reminder is 0. So in which form is this? It is in the form 2 into q. That is, it is in the form 2q. If you want to check for this 4q plus 2, once comment me down. How did you confirm this 4q plus 2 is even? And what number you are taking to get this of the form 4q plus 2. So that's all for today's class. In this class, we covered example 1 and 2 with a small explanation. I hope you understand the concepts clearly. Don't forget to practice more problems from your textbook. If you found this video helpful, please like, share and subscribe to the channel for more lessons and discussions. In the next class, we'll see few more problems on this method to understand you better. So that's all for today's class.